So the various ways of specifying data are called the addressing modes. So I hope you have watched the video of the addressing modes. So in different ways of specifying data are called the addressing modes. Although microprocessor instructions require one or more words to specify the operands, the notations and the conventions used in specifying the operands have very small to do with the operation of the microprocessor. The mnemonic letters used to specify a command are chosen by the manufacturer. When an instruction is stored in the memory, it is stored in binary code. The only code the microprocessor is capable of reading and understanding. The conventions used in specifying the instructions are valuable in terms of keeping uniformity in various programs and in writing assemblers. The important point to remember is that the microprocessor neither reads nor understands the mnemonics or the hexadecimal numbers. So there are specific opcode formats. In 8085 microprocessor. To understand the operation codes, so we need to examine how an instruction is designed into the microprocessor. This information will be very useful in reading a user's manual in which operation codes are specified in binary format and 8 bits are divided in various groups. However, this information is not necessary to understand the assembly language programming. So, in the design of the 8085 microprocessor chip, all operations, registers and status flags are identified with a specific code. That code or that format is our opcode format. For example, all internal registers are identified as follows. You can see in the board. So if the code is 000, then by default the register will be B will be selected. For 001, C will be selected. For 010, D will be selected. For 011, U will be chosen. For 100, H will be chosen. For 101, L will be chosen. For 111, A accumulator will be chosen. And for 110, it is reserved for the memory related operation. So it is 110 which is reserved for memory related operation. Fine. So if the code is like this, then automatically these registers will be chosen. And if codes are 00011011, then BC register pair will be chosen. For 01 D register pair will be chosen. For 10 HL register pair will be chosen. For 11 flag or stack pointer will be chosen. Fine. So means there are specific formats or there will be specific registers to be chosen for a specific code in 8085 microprocessor. For each and every corresponding code, there will be different registers selected and there will be also some registers pairs selected. Means if you are using 10, then obviously manufacturer will select HL pair. So if the code is 00, automatically BC will be chosen like this. If you are having code 001, automatically C registers will be chosen. Instead of having for 001 for 010 for 110101, automatically some register will be chosen. And for code 00011011, some register pair will be chosen. Fine? So some of the operation codes are identified as follows. For different function and the corresponding operation code has been given here. So first function is to rotate each bit of the accumulator to the left by one position. So this is our first function. Rotate each bit of the accumulator to the left by one position. The corresponding operation code will be 00000, means 5 zeros and 3 ones. So the hex code will become 07H. So means here the opcode is of 8 bit. So we get 8 bit opcode here. So for second function, this is the add the contents of the register to the accumulator. Means you can add the contents of any register to the accumulator. Fine. So the operation code will become 10000 SSS. So means these last 3 S are reserved for a register, and this first 5 bit will be our opcode here. So here 5 bit opcode and 3 bits are reserved for a register. So we have two functions. First function is to rotate each bit of the accumulator to the left by one position. We will get the operation code like this. For second function, add the contents of a register to the accumulator. The operation code will be look like this. So remember one thing, that for the second operation code 10000 SSS, first 5 bits are the opcodes and last 3 bits are reserved for a register. But for the first operation code, all are means accessible to the users. Means programmers can use all these 8-bit opcode. Means we have the access of 8-bit opcode for the first case, and for second case we can access only 5-bit opcode. We have only 5-bit opcode. So last 3 bits we cannot access. So last 3 bits will be reserved for a register by the MUP itself. Fine. So this instruction is completed by adding the code of the register. For example, we want to add 10000 to a register B that contains 000. So obviously register B will give the answer to register A, means accumulator. It is implicit. So the corresponding binary instruction will be 1000 and B register contains 000. So the corresponding hex code will be 80H. 10000 is 8, 000 is 0. Fine. So first 4 will be 8, last 4 will be 0. H. So these first 5 bits are for add and last 3 bits are coming from register B. So simply in assembly level language, this is expressed as add B and the corresponding hex code will be 80H. So the opcode is add, operand is B, hex code will become 80H. So now opcode is add. So opcode contributes 10000. Operand is B, B contributes 000. So the operation is to add with add B. So the binary instruction will become This is for add first 5, last 3 is for register B. So total overall it will become 10000000 means 808. So in assembly level language, simply we can express this code as add B, where add is our opcode, B is our operand, and corresponding hex code will become 80H. Fine. Previously, we have taken two functions for two different operation code. So first function was rotate each bit of the accumulator to the left by 1 position, and the second function was add the contents of a register to the accumulator. Now the third function is move, that is copy the content of register RS, that is source, to register RD, that is destination. So now the function is move, copy the content of register RS, that is source, to register RD, that is destination. So obviously source will be our accumulator and destination can be any register. So the operation code is 01, means it is a 2-bit opcode for this move operation. DDD is the register, that is RD. RD is the destination register. SSS is the register RS. RS is the source register. Fine. So for this specific function, move the content of register RS, that is source, to register destination, means from B to say A, from C to A for example. So C to A, C will be our destination, A will become our source. Fine, like this. So it will be 2-bit opcode 01. DDD will be for register RD, SSS is for register RS, where RD and RS are the destination register and source register respectively. Fine. So this instruction is completed by adding the codes of two registers. For example, move the content is 01. To register C, it is 001, that is DDD. From register A, say suppose it is 111, say SSS. So binary instruction will become 01 001 111, means 01 001 111. First two coming from the operation of the move 01. Second, then fourth, fifth and sixth, third, fourth and fifth are coming from DDD. Then sixth, seventh and eighth are coming from RS, SSS. So it become binary instruction will become 01 001 111. So first 2-bit 01 will be our opcode and last 6 will be our operand. So 0100 will be 4, 1111 will become F. So corresponding hex code will become 4FH. Fine. So the instruction can be completed by adding the codes of two registers RD and RS. So for move it will be 01. To register C, suppose it is 001. From register A, suppose it is 111. 001 111 can be anything. So this is just an example. So if we want to get the binary instruction out of this, means move register C, A. First, the operand is C, A and the opcode is to move. So operation code for move is, say suppose 0 1. So operand is C, A, means from C to register C from register A. So suppose let us take to register C, means DDD contains 001, and from register A SSS contain 111. So final binary instruction will be 01, 001, 111, means first 01 will be opcode, 001, 111 will be our operand, means 01, 00 will become 4, 1111 become F. So the hex code will become 4FH. Fine. So in assembly level language, how to write this? Opcode is move, means copy. Operand will be C, A, and hex code will be 4FH. So if you write this assembly level language, so inside the microprocessor, this sort of action is always being takes place. Fine. So simply we are writing opcode, operand and hex code in assembly level language, but inside the MUP, inside the microprocessor now. So these instructions are being executed like this. Fine. So in assembly level language, opcode will be move, MOV move, operand will be C, A, and the corresponding hex code will become 4F. Fine. So please note that the first register is the destination and the second register is the source. From A to C, which appears reserved, means from A to C, which appears reversed for a general pattern from left to right. Typically in 8085 users manual, the data transfer or the copy instruction, you can see the copy instruction will be given or can be written as this. Fine. It will be move, then it will be for register 1, it will be for register 2. Fine. So 01 DDD SSS. So move, for move it will be 01, DDD is for register, destination register, SSS is for source register, or simply you can write R1 and R2. Fine. So these are the basics of this opcode format. Hope you have understood this. So this is also very important in terms of any competitive exam. You can take GATE or any semester exams also. So very conceptual but tricky question, or you can say answer will be of one line, but the concept will be of 30 minutes class. So that this sort of questions may come in your exam also. So I'll try to share some previous year question to you so that you can get an idea how in different years questions are coming. I will also share some GATE question to you so that also you can identify that these questions or these sort of questions are coming in different years in GATE, so that you can accordingly you can prepare yourself for the upcoming GATE examination also. Fine. Thank you all for attending this class. Thank you. Take care. Stay safe. Stay connected.